Hi, y'all. So I'm going to quickly go over the quiz questions it was an online for quiz one. I just wrote them out by hand. I figured that would be good enough. And I'm just going to go over how I would solve each of these problems. So these were multiple choice, but I'm just going to treat them as free response because your future quizzes will be free response. So hopefully that works for y'all. So this first one just asks, what are the major products? I'm going to try to change my camera angle a little bit so you can see my hand while I'm writing. So whenever I see an epoxide with acid, I always go through all my major reactions. Is it acid base? Is it substitution elimination? Well, technically, if you have any oxygen with electrons and an alcohol, that first step is acid base. It protonates it. So you always get this acid-base reaction initially, but then you have to ask what happens next. And you can go through your whole long list, but hopefully you remember that we actually talked about epoxides in chapter 12 with ring openings of epoxides. I guess it was chapter 11 and 12. We talked about reactions of alcohols and ethers, and that's when we did ring opening of epoxides. And we talked about how base catalyze attacks the least substituted side, and acid catalyze attacks the most substituted side. And I have a whole video specifically talking about ring opening of epoxides. I talked about with acid catalyzed, which that's what this is. The H plus indicates that it's acid catalyzed. That really a partial positive happens on the more substituted side right here. It's almost like an SN1 reaction where this bond starts to break and there's a partial positive here. The electrons are being pulled towards that oxygen. And then your alcohol will come in and attack and that bond will fully break and you will get your epoxide ring open. So your OH is still attached over here, but it's not attached on this side anymore. Instead, you have your OCH3, and that is still protonated just because it had the hydrogen on there initially, but it will be deprotonated usually in like a workup step. So you'd get something like this. And that should be your final reaction. I always like to just double check and make sure that I have numbered my ring 1, 2, 3. So 1, 2, 3. So the bond between I'll start over here. 1, 2, 3. So the bond between carbon 1 and the oxygen is still there, and between 2 and 3 is still there. The bond between 1 and the oxygen has broken, and between 2 and 3 is still there. So that looks right here, and the attack happened on the more substituted side, which is also carbon 1 in the way I had it numbered. So I did not lose any carbons. So that looks right to me. Okay, the next one, again, you got to go through your list. Is this acid base? I don't see anything acid base. Substitution elimination, well, there's not a good leaving group. It does sort of seem like it's substituting. So, what's going to be a substitution? I'll put that there, but it's nothing standing out to me. And this question, you're trying to make this transformation happen. So then I think about what came after that. Let's see, substitution, elimination, addition reactions. There's no double bonds, so it's not that. So then I go into reactions of alcohols, and we learned one way to make alcohol a good leaving group using PBr3. Well, we learned many ways, but PBr3 is one of them, and it turns it into a bromine. But if you might remember, it goes by SN2 reaction, so it is a substitution reaction. But that means it has inversion of stereochemistry, so it would look like this. Well, hopefully you recognize that this is actually the same molecule as this flipped over. So this is kind of a tricky question. So when I first saw this, I was like, wait, that's not the right answer because it needs inversion of stereochemistry. And then I realized it did have inversion of stereochemistry. We had just flipped the molecule over. So this is actually tests you on a little bit of chapter 5, chapter 6 for substitution, and chapter 10 all at once. So hopefully you got that one. But yes, so the right answer is PBr3. I always forget to write the 3 on that. Okay, and then question 3 is, what is this species that's effectively acting when you reduce LAH or a carboxylic with LAH? And I've showed this to y'all a few times. I actually just write it as H minus because that's essentially what's happening is H minus is coming in here and attacking. and you get this. So the right answer to that question is H minus. That's basically what's acting, is H minus is generated by the LAH. And then the last question is, we have a secondary alcohol that reacts with SlCO2 to become something, and then it reacts with LAH and acid to become something else. Well, if you have alcohol with SOCl2, similar to PBr3, we'll turn that into a chlorine if it's primary, secondary. Tertiary, that doesn't work. It would have inversion of stereochemistry, but stereochemistry isn't given us in the first step, so it doesn't matter. And then LAH actually reduces halogens, basically just gets rid of them. So your final answer would look like this. And then the very last question is a Grignard, as a bonus question. It's about Grignard reagents, and it actually asks, why do you have to do Grignards in dry solvents? And that's because dry in organic chemistry, I talked about this in the group work video. We had the same exact question, but dry in OChem basically means no water. And that's because if you have a Grignard reagent like this, if it's MgBr, that is essentially a carbon ion. And if you put that anywhere near anything acidic, it will just snatch up that acidic proton, and basically it completely neutralizes the reaction. So the reaction can't go anymore. Okay, well, I hope that was helpful for you. And if you have any questions about this quiz 1, let me know. Happy studying!